Hi everyone. Do you find reading of normal distribution table difficult? Don't worry. In this video, I'm going to show you how you're going to read the normal distribution table to find out the different probabilities for different z values. This is a normal distribution table where you will see values of z starting at 0, 0.0 and it will be up till 2.9 or sometimes 3. You will also see a bell-shaped symmetrical curve shaded from negative infinity to some value z. This shaded region is denoted by phi of z. The area under the shaded region is what we are going to find in the given table to get the required probability. Note that the total area under this curve is always equal to 1. And this axis of symmetry at 0 is going to divide it into two equal parts. That is 0.5 on each side. Let's see how to find out the probabilities for different values with some easy examples. So suppose the question asked to you is find out the probability of z less than 0.23. Whenever you are finding the probability of z for any point, always have a habit of drawing a curve. It could be just approximate curve, but then just draw it so that you understand what is exactly asked to me and then how I'm going to find it from the table. 0 is at the center. So approximately here I will get 0.23. So if this is 0, what do I mean by z less than 0.23? This means this shaded part from negative infinity to the point 0.23. If the question asked to you is like this, wherein the point over here is positive and the inequality is less than, I'm directly going to get my answer in the table. So how do I search this in the table? First, I have to search for the value 0.2. So 0.2 row is this. Now I have to search for column 3. So column 3 is here. Now the value that you see across 0.2 and this column 3 is 0.5910. So this is your required answer for the probability z less than 0.23. So from this entire curve, which is 1 as the full area, my area till the point 0.23 is 0.5910. I told you till 0 it is 0.5. So definitely you're going to get the value from this 0 to here as something like 0.0 something something. So it has to be more than 0.5. Okay. So in this table, you're going to get all the values more than 0.5. So the value here is 0.0910. Suppose the question asked to you is to find out probability z less than 1.345. Earlier, you have just seen 3 digits. Now I have 4 digits. So first I am going to check for the row 1.3. So my row 1.3 is here. Now search for the column 4. So for column 4, I get 0.9099. But this is not my final answer because I have one more digit here. So for this digit, what am I going to do? Now continue along the same row to column 5 in the far right. So I get this value 8. Now this 8 I am going to add up with the previous value. But how I am going to add this 8? 8 is not integer that you are adding here. This is actually 0.0008. And when you do this addition, you get the value as 0.9107. So this is your required answer. For probability z less than 1.345, my answer is 0.9107. So if I share this and see, let's see 1.3 somewhere here. So what is it less than 1.345? It is almost 0.9107. That is 91% of the area is covered till 1.345. Now we have seen in both the examples for the same inequality, that is less than. What do I mean by finding the probability for greater than inequality? So suppose the question asked to you is to find out z greater than 1.345. I'm purposely taking the same point because now you have understood how to get the value from the table. Now you need to understand for the different inequalities and for the different values, like if it is positive, if it is negative, if it is within the range. So let's see some examples like this. So now you have to find out probability z more than 1.345. I will first show you the region. So I have here 1.345. I'm just drawing it approximately. What do I mean by z more than 1.345? That means this side, more than side. Now when I'm interested into finding the area here, and in this example, are you able to relate these two? The shaded region over here is something different than what I am able to see here. But still, do you get any kind of connection in between these two diagrams? Yes, you got it correct. They both are complements of each other. I already know that the total area under the curve is 1. So if I'm interested into finding the leftover area, I am going to subtract the value that I got here from 1. So this probability z more than 1.345 is actually equal to 1 minus phi of 1.345. What do I mean by phi of 1.345? The value that you get directly from the table, the one which we have computed here, that's 0.9107. So I get 1 minus 0.9107, and that's equal to 0.0893. I hope this is clear to you. Now let me tell you about some negative values. Suppose I have to find out for the negative value. The question is, find the probability z less than 1.345. So to find out the probability z less than minus 1.345, let's first draw the region. Approximately here I will get minus 1.345. What do I mean by probability z less than that point? So less than that point means still minus infinity. When you're interested into finding this, I told you at the starting that this curve is symmetric. So if I have z over here, exactly from the same distance, I am going to get minus z. This 0 is an axis of symmetry. It divides your entire curve into two equal parts. So if you have z, exactly from 0 to minus z, you're going to get the same distance. And therefore, the shaded part over here and the shaded part over here would be exactly same. So the answer for probability z less than minus 1.345 is same as this, which is nothing but 1 minus phi of 1.345, which is equal to 0.0893. Now let's see what happens when the question asked to you is to find out probability z more than minus 1.345. So when you draw this region, you see nothing but this shaded would be the required region. So minus 1.345. Now if you remember the first example that we did, it was about finding the probability from negative infinity to the point 1.345, and this was the shaded part. Do you see these two are the exactly same shaded part? So the value of the probability is also similar, and that value is nothing but 0.9107, the first thing that we have computed from the table. So when you're interested in finding the probability z more than a negative point, it is similar to the phi of that point. Okay, now let's see some questions wherein you will be asked to find out the probability between 2 points. So let me take some 2 points and show you. So if I have to find out probability of Z between AB and both the values A and B are positive, let's draw the region. So I have both the values positive, so it is definitely going to be after 0. Let's say A is here and B is here. A is smaller than B. And the question asked to me is to get this region. So to find out this region, you will have to find out value from the table for B, that is nothing but phi of B, and subtract phi of A from that. And then I will be able to get this shaded region. How is this possible? See, when I'm finding phi of B, I actually get this particular region. And when I find till A, I would get the region till A. Now, when you subtract these two diagrams, what you will get? Nothing but this particular part, this strip, A to B. Okay, so what you're going to find? We find phi of B and then we subtract phi of A from that. You get nothing but probability Z between the 2 points A and B, where both A and B are positive. Let's see what happens when A and B are negative. So you have both A and B values negative over here. A is more than B. Let's say A is first and B is here. So I'm interested into getting this region. Now do you see these two are exactly mirror images of each other? So whatever part shaded over here is the same part that is shaded over here. And I will get exactly same answer for this particular region. So it is phi of B minus phi of A. Now let's find out some examples wherein one value is at negative side and other is at positive side. So in this case, I have A as negative and B as positive. So to find out the region in between this minus A and B, I have to first find out probability till phi B. That is, till this point, I'm going to find out the probability. I'm going to add up probability of A and then I'm going to subtract 1. Now, why is this? See, when we are finding probability, this phi of B, when we are finding, we basically get this entire region from negative infinity to the point B. When we are finding phi of A, what we are basically getting is this entire region. I'm just flipping it and showing. Okay, so this A is suppose flipped up. So this minus A would give you same answer. So this is what you're getting. When I add these two, suppose you keep this image over it, what do you get? I would be able to see that till B it was shaded. And when I add this part also, I would get it is shaded like this. So my entire area would be shaded once and this in between part is shaded twice. So this entire part, the entire diagram is shaded once, but this in between part is shaded twice. So when I am just subtracting 1 from this addition, I will be able to just get A to B. So this in between part is what I will be left out with. I hope this is clear to you. Try to find out the answers for some points, like take some two examples, try to find out the values and see whether you are able to get it. So you can check it for minus 1.2 and then you can have your 0.5 for example. Try to find out the region in between that. Okay. Tell me if there is any problem. You can ask me in comment box if you have any queries. Thank you for watching.